This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 1, Lesson 4, Cooling and Dehumidification. When a cooling coil runs colder than the air's dew point, water condenses on it. On the psychrometric chart, the air moves down and to the left. Temperature drops and humidity ratio drops together. The load now splits in two, a sensible part that lowers temperature and a latent part that wrings out moisture. We'll set the sensible plus latent split, work one coil, and check that the parts add to the total. Concept 1, the wet coil. When the coil surface is colder than the entering dew point, it cools and dehumidifies at the same time. Temperature falls, so the air moves left. Vapor condenses and drains, so the humidity ratio falls and it moves down. The process line heads down and left toward the saturation curve. One caution before the method. Textbooks describe a wet coil with apparatus dew point and bypass factor, the effective coil surface temperature, and the fraction of air that slips through unchanged. Neither is in the handbook. If a problem needs them, it defines them. On exam day, work the load straight from the printed sensible, total, and latent split. Concept 2, the split. For standard air, the handbook gives 3 one-line loads. Total is 4.5 times the airflow times the enthalpy change. Sensible is 1.10 times airflow times the temperature change. Latent is 4840 times airflow times the humidity ratio change. And they must reconcile. Total equals sensible plus latent. Compute any two, and the third follows. Concept 3, the condensate. What separates a wet coil from a dry one is the water dripping off it. A dry air mass balance gives the drain rate. Dry airflow times the drop in humidity ratio. The handbook also prints the full energy balance with a condensate enthalpy term. The 4.5 enthalpy shortcut is just its standard air shorthand, and it's all you need on the exam. Setup: 4,000 CFM of standard air, entering at 80 degrees and 0.0155, leaving at 55 and 0.0090. The enthalpies come straight from the printed moist air relation. 36.2 in, 23 and round numbers out. Temperature drops 25. Humidity ratio drops 65 ten-thousandths. Enthalpy drops 13.2. Now the loads. Solve. Part 1. The total. Plug the two states into the enthalpy relation. 36.2 in, 23 out, a 13.2 drop. Total load is 4.5 times 4,000 times 13.2, about 238,000. That's the whole coil capacity. Now split it. Solve. Part 2, the split. Sensible is 1.10 times 4,000 times 25, 110,000. Latent is 4840 times 4,000 times 0.065, about 126,000. Add them, 236,000, within 1% of the total. That gap is just rounding in the standard air constants, and the coil drips about 117 pounds an hour, roughly 14 gallons. Traps. 5. 1. Don't forget latent. On a wet coil, the sensible load alone is about half the truth. 2. The leaving air temperature is not the apparatus dew point. The coil surface is colder. 3. Sensible and latent must use the same airflow before you add them. 4. Take humidity ratio entering minus leaving, so delta W is positive. Flip it and latent goes negative. 5. The sensible constant is 1.10 in the handbook, not the trade value 1.08. Quick recall. A wet coil moves down and left. Total is 4.5 times airflow times enthalpy change. Sensible 1.10 times temperature change, latent 4840 times humidity change, and they must sum to the total. Condensate is the dry airflow times the humidity drop. Golden rule: below the dew point there is always a latent load. Never hand back the sensible number alone. Next up, Lesson 5, Humidification. The wet coil pulled water out. Now we put it back with steam or a spray, moving the air up the chart. The added water's enthalpy sets the direction, and the same latent shortcut returns with the humidity change, flipped positive. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.